Welcome back. We're looking at section 2.8 for this lecture, which is talking about solving linear inequalities. Now, unlike an equation, an inequality does not necessarily have to equal one side to the other. Instead, it's a slightly different type of relationship. As far as section 2.8 is concerned, you do have a section with some beautiful notes and a chart. Let's go over those just very, very quickly. So let's get some signs first. We have to understand what it is we're looking at. Inequalities will use signs such as greater than, I should say, less than for comparison purposes, and you may also have greater than or equal to and less than or equal to. Now there's a few different things. It sounds very similar, but there's a few different key things here that make these symbols different. Whenever you're talking about greater than or less than, you're talking about one item being greater or lesser than another. For example, 5 is greater than 3. 3 is less than 5. Those would be ways of comparing two different values. If I'm looking at something where it can possibly be equal, that's the key difference between these signs. Notice there's a bar here on either of these two signs. That is indicating that a value might be equal. So if I say x is greater than or equal to 5, x could be 5 because it is equal to, hence the equal to, but it could also be greater than that value. It could be 6, could be 7, could be 5.2, could be whatever it happens to be. And that means that we are looking at a range of values for that solution. Now, there's a couple other symbols that go along with this. I'm going to put a little dividing line here. Doesn't mean anything, I'm just dividing out my two separate sections. When we're graphing, these are not included values, which means we typically use an open circle and we use parentheses. So whenever we're talking about our notation for values, or if we're graphing, we can use parentheses to indicate that these values are not included in the comparison, meaning they can't be equal to. They can get very, very close to, but they cannot equal those values. Contrastingly, if you have the ability to be equal, these values are included in the solution set, which means you may have seen a dark filled in circle, or more commonly, square brackets as part of the notation. So with that in mind, let's go ahead and just try a couple problems. So the first problem that we're going to try, and this is simply talking about graphing and then giving the notation. X is less than or equal to negative 4. So if x is less than or equal to a negative 4, for graphing purposes, well, some of you may like to have the perfect number lines where every value is specified for you, and that's perfectly okay. I tend to go with what value do I actually need to show my representation. In this case, this is already simplified. I'm looking at just a negative 4 as the value of concern. Now, here's a big tip, if you will. Add a couple values to either side of this negative 4 just to see what values are around. So on the left, this is a negative 5. On the right, this is a negative 3. This kind of helps you understand what it is you're looking at on the number line if you need a visual cue. X is less than or equal to. We'll come back to that equal to part. Less than. The question is, which direction is less? Going in the direction of negative 5 or going in the direction of negative 3? Well, in this direction, from a negative 4 you're increasing your values. You're going closer and closer to positive values, eventually into positive values. On this side, you're going further and further into negative values, which increasingly get small. That means this is your lesser section. Okay, now I did say we'd come back to that equal to component. The question is this going to be a solid circle or an open circle? And because we can be equal to, you would use a solid circle or you would use a square bracket. For the purpose of this problem, I'm going to show you both, but moving forward, I will use the brackets and parentheses. So you can use a solid circle just like so that you can see that this is an included value, or you can use a square bracket with the line going in the same direction. What that means is we are now looking at an included value and we are graphically representing x is less than or equal to -4. Now, as part of the instructions for this problem, aside from graphing, it says give the interval notation for each. Whenever you're looking at interval notation, it's actually far easier than what it sounds like. You're looking at the range of values that you could easily represent very quickly in a non-expressional form. What that means is I'm looking at everything over here being negative infinity up to this stopping point of -4. I'm going to put this negative a little higher. There we are. So I have negative infinity to -4. Now, here's why the parentheses and brackets are very, very important. I know this -4 is an included value. I can use a square bracket to show that. So this is an included value. Now, infinity can never actually be included. Positive or negative, doesn't matter. Infinity keeps going. So there's no way to add a boundary, if you will. That being said, infinity is always closed with a parenthesis value. Excellent. Let's try another one. Very quick, very small amount of room, so we can do that right here. Put a little wavy line just to kind of show a distinction. So I have 6 is less than or equal to -x. Now, there's a couple different things that you can do here. We don't tend to like our variables as negatives. And the reason for that is it's basically telling us it's an opposite value. But we want the true value. We want it as simple as possible. So what you can do are two different things. One, you could multiply by a -1 to both sides. In doing so, this becomes positive, so you have x. This becomes -6, but this part's very, very, very important. If you multiply or divide by a negative in any inequality, the sign reverses. Very important there. So what we're seeing now is that -6 is greater than or equal to x. Or you could see this reading from the variable and just putting a line here to kind of show like a mirror. If you were to flip this over, look at it in a mirror, x is less than or equal to -6. These two statements are saying exactly the same thing. It's just a matter of perspective. So one thing I always suggest is that you read from the variable. Read from the variable. It doesn't matter where the variable is, read from that value. What we're seeing is, looking at this one first, x is less than or equal to a -6. Well, x is on that lesser side. If you notice the symbol, the little pointy side here is always indicating the lesser side. So x is on the lesser side of a -6, and it can possibly be equal to. So you can read this either way, and that is perfectly fine. Graphically, what we're going to do get our number line. Our value of interest is -6. And the question is, which direction are we going to? Well, x, the unknown, is on the lesser side, which means we are in this direction. Are we using a square bracket or a parenthesis to represent this? Well, we can include, so we will use that square bracket. And so there's our graphical representation. If we're talking about our interval notation, over here is infinity, so it's a negative infinity. Remember, that's always a parenthesis on any of the infinity values. And you're going up to a -6, stopping and including that -6. So you use a square bracket for that. And that's it. That's probably the hardest concept as you start moving through inequalities, is understanding the relationship and really understanding the process on how you represent that relationship, either with brackets or parentheses. You can use the closed circles and open circles, though your textbook may not show that per se. That being said, let's get some board space. And let's work through some problems, because again, this is as complex as it really gets for understanding the relationship. As we start working through some problems, you'll see how additional steps get put in. So let's work on this next one. We have a -4 is less than or equal to x, which is less than 9. Now you might be saying, wait a minute, you just lied to me. We said that was as complex as it gets. Now you're showing me a problem that has 2 inequalities in it. That is okay. This is a compound inequality, meaning it does have 2 different inequality relationships. You could technically split this problem up and see that you have a -4. -4 is less than or equal to x, and x is less than 9. You could absolutely do that. And if you do, I want to show you the graphical. The graphic would show you from a -4, which is on the lesser side of x, so x is technically on the greater side of this -4 going in this direction. It can include the value, so that's a square bracket. Likewise, x is less than 9, which means x is on the lesser side of 9. It cannot include this value, so that is a parenthesis or an open circle. And putting these two together, because it is an and, it is compound, it's both of them, what we can see is that we have a -4 and a 9, and those are boundary values. We know that -4 is included. We know that 9 is not included. Everything that overlaps between these two statements is the solution. So x can be any value from -4 to 9, but not including 9. That's exactly what this statement is saying. So when you're looking at this compound inequality, while it may look like it's a lot of pieces, it's simply 2 expressions. You're going to put these inequalities together and create your graphical solution, this being your graphical solution right there. Your interval notation is actually super easy here because it actually specifies it for you in the graphical representation. You have -4, which is included, to 9, which is not included. And that is your interval notation. Again, that was as complex as it gets, right? Very simple as you're looking over the problems in general. Let's do another problem. I'm going to get some board space just because it does tend to get a little messy if we have several items up here at the same time. So the next problem is actually saying solve the linear inequality for x, graph the solution, and give the solution in interval notation. The inequality they give us is -x plus 4 is less than or equal to -6. And I know what you're thinking. You're like, you lied. It's getting even more complex. There's more stuff. It's actually the same exact thing that you've been doing so far the entire course. All you're doing is working with one variable, basically one two-step equation, if you will. Because of this inequality, you're looking at a comparison of relationships as opposed to a balance. So what we're going to do is we're going to move that 4 over. We're subtracting 4. Whenever you add or subtract values across the inequality, the sign does not change. But because this is a negative x, we're going to multiply by a -1. Remember, whenever you multiply or divide by a negative value, the sign does change. So this is x is now greater than or equal to 10. Excellent. So we've done that part. We've simplified it. We need to now graph it. Our value of interest is 10. X is on the greater side, so x is in this direction over here. And it can be included. So we're going to put a square bracket. And what that means is that x has a solution set from 10, including 10, to a positive infinity. Remember to use a parenthesis to bind that infinity. Okay, let's do another one. That one's fairly simple. You're going through just really rearranging the problem like you did on just regular equations. The one thing that you have to remain conscious of the entire time is if you're multiplying or dividing by a negative number, that will reverse the sign of your inequality, as it did in this case here. Okay, getting our board clean. Let's get another problem. So the next problem is 2 times a quantity of x minus 3 minus 5 is greater than 3x plus 2 as a quantity minus 18. It says solve, graph, and give the solution an interval notation. Very good. So at this stage, I see a few things that we can do. Let's just play like it's a regular equation. Let's see how it works. So distribute, I have 2x minus 6 minus 5 greater than 3x plus 6 minus 18. Combine your terms. This is going to be 2x minus 11 greater than 3x minus 12. Once you combine those terms, don't drop your signs. I like to keep my variable positive. It's just how I am, positive person. I'm going to move my 2x over. That means this is just x. I'm going to add my 12 over as a result. This becomes 1. My sign did not change because I did not multiply or divide by a negative value. So my sign did not change. So I have 1 is greater than x, or x is on the lesser side of 1. Value of interest is 1. X is on the lesser side, which is over here. It cannot be included, so I use a parenthesis. My interval notation goes from a negative infinity to 1. 1 is not included, therefore it has a parenthesis. Okay, pretty easy, pretty straightforward. Let's jump to the next problem. So the next problem, had to find my place, is a little bit like what we saw earlier with that complex, or that compound inequality rather. And it's only a little bit more of a complex version of it, that's all. Now, what I'm looking at here is a compound inequality. You know that because you have two inequality signs. And there's a couple things that you can do here. So I'm going to show you two different ways to solve this problem very, very quickly. If you're looking at this problem from the perspective that we said earlier, it's two separate inequalities. This is what you would do. You would rewrite it as -1 less than or equal to 2x minus 3. And you'd have 2x minus 3 is less than 5. And then you would go through and solve each piece. So you'd add your 3 over, that gives you 2 less than or equal to 2x. Solve, that's x is on this side, 1 on this side, so 1 is less than or equal to x. X is on that greater side. Over here, if you were to solve this out, you would add your 3, so you'd have 2x less than 8. Divide by 2, x is less than 4. And then you'd look at these and combine them back, and you would say that 1 is less than or equal to x, which is less than 4. So you kind of took this problem originally, you split it up into two separate problems, you worked it all the way out. Just don't forget to combine it at the end. When you graph, you would have 1 and 4 as your points of interest. 1 can be included. X is on that greater side of 1, so it's going in this direction. X is on the lesser side of 4, so it's going in this direction, and that 4 cannot be included. Your interval notation is bracket 1 to 4 parentheses. So this is one way of solving this problem, and this is perfectly fine if you want to go through and solve your problems just like this. It's very clear. You can see the individual parts as you're working through the problem. Alternatively, get my squiggly line, there we are. I have a -1 less than or equal to 2x minus 3 less than 5, just to get my problem back up here. The alternative way of doing this is not separating your problem. Here, I suggest writing in your steps. You're going to add 3 to every side. I know you're used to saying to both sides, but you have 3 sides here. 2 signs, 3 sides. So you have to add 3 to every side. That cancels it here. That gives you a 2 less than or equal to 2x, which is less than 8. Looks pretty familiar. Divide by that 2 to every side. That gives you x in the middle. Your signs did not change because that was a positive 2. So your signs did not change. This is a 1. This is a 4. It's exactly the same. So from this point, you would do the same thing. You'd go to graph, and you would also go to your interval notation here. So either way, it doesn't matter. This one does save you a few steps, a little bit of handwriting, a little bit of page space, and that's perfectly fine. Or you can also split it up and you can see both sets of components. That way you can see everything as you work through. Okay, guys, that concludes section 2.8 for this lecture. And stay tuned, we will have another lecture coming up soon.